Assalamu alaikum wa rahmatullahi wa barakatuh. This is Saad al-Sharif alongside my colleague Nizar al-Himaydi. Today we are presenting to you our project which is called City Emergency Traffic Management. The idea is to ensure fast arrivals for emergency vehicles by altering the duration of traffic lights alongside the intersections leading to the emergency location. To do this, we are assuming that we have three emergency locations located here for the police station, here for the ambulance or medical center, and here for firefighters. All three of them are controlled through a control center, which we're assuming it's here. Let me zoom in. Uh, these control stations are controlled by three control centers responsible for each one of them. These control centers are connected by switches using a spanning tree protocol, which ensures availability at all times, even during failure of any of the switches. The switches then are connected through the switch to a router and another topology of routers that are using the EIGRP protocol. We have this topology. One second. EN. Show. Yeah. We have this EIGRP topology, which is the routing table to send any packet or any signal to the desired location. Now, the routers finally reach their destination, which is the Raspberry Pi chips controlling four lids, which represent the traffic lights for an intersection. As stated, uh, we have three control centers: police station, the ambulance, and the firefighter. All of them are controlled by their respective control centers. And each control center, for example, the firefighter here, has the our application, which is a traffic light controller. Uh, so before we go into the demo, for the sake of this example, or for the sake of this demo, all the traffic lights are running at somewhat high speeds. For example, here, it's running at somewhat of a high speed, all of them. Now, we go to the firefighter. We, all right, let's say uh, we have a fire. All right, let's move this later. Let's say we have a fire located here, for example, or here. The nearest intersection to it is traffic light number 2. We're numbering it as number 2. So all we have to do is we go to the firefighter, we run our application, and we select TL2. Now, what's gonna happen is that the traffic lights will change the rate they operate at. So we have the intersection at T7. As you can see, this traffic light is staying longer than the other three traffic lights. What this does is make sure that this street or this side of the street is less jammed with cars than the others. So it ensures faster movement for the firefighter vehicle. Uh, the next intersection our way is T5, also having this traffic light operating at a longer rate than the other traffic lights. We then arrive at T6, we're assuming we're taking this path, so this traffic light is operating at a faster rate than the others. We finally get to T4 for this one to operate faster than the others. Finally, T2, we arrive at our location. Once we get confirmation that the vehicle has arrived to its location, we simply send a reset signal, and now all traffic lights are back to their normal rates. For example, here, the traffic lights are back to their normal rates. So let's have another case where, say, we need an ambulance at intersection 4. We need an ambulance here for some reason. Now, we go to the ambulance control center, sorry. We run our program and we select T4. Now, the ambulance is starting is initiated from here. So we have this traffic light operating faster than the others. It's gonna go through here, and then it's gonna go through T5. After T5, it's gonna go to T3, and finally, it's gonna go to T4. It's gonna arrive to T4. Again, once we get confirmation that the vehicle has arrived, we will send a reset signal, and now all the traffic lights are running at their normal rate. Let's have a final example. Say we need a police station at T7 this time, here for example. So we go to the police station, we run our application, and we select T7. Now, the police station is located here, so this traffic light is operating faster, longer than the others. It then moves here at this intersection, and then finally here. Now, let's go over the code we are using. For example, the code we're using for the firefighter. Okay. For communication, we are using the UDP protocol uh, for several reasons. Mainly that the UDP is connectionless, so that we don't have to worry about establishing multiple connections or maintaining them or terminating them. We simply send whatever we want to send, and we don't have to worry about anything else. We are also using a GUI interface, which is implemented through HTML, a simple GUI having 7, 8 buttons and the picture that was used in the interface. Each button will simply just send its name to the main program. Uh, Here in the main program, we have this function or method to fetch the type or the name of the button that was clicked. We have also these initialization steps for the GUI interface and the UDP protocol. Uh, After we fetch the name of the button, which is the type, there are several if statements dedicated to each button, which basically determines the path used. And finally, at the end of every if statement, there is the reset. We're resetting the type variable so that it doesn't continuously send it. And we have the reset signal, which sends zeros to every intersection. Now, let's go to the Raspberry Pi code, for example, this one. Uh, we initialize the UDP, and each Raspberry Pi, as you can see here, is connected twice to every LED. Mainly, the reason for that is one pin is used for the green and one pin is used for the red light. For the sake of this demo, as stated before, we are running each intersection at very low intervals. The intervals are determined by this value here, which is D1, D2, D3, D4. 500 is relatively low, but as stated, this is for the sake of demo. The data is fetched here. Here, we're storing it in F. It's called F data. Now, during the while loop, the F data is changed to X data, and depending on the input received, traffic lights will alter. We assigned number 1 for the north traffic light, 2 for the west, and 3 for the south, and 4 for the east. So, depending on whichever value we received from the UDP connection, we're setting the interval for that specific traffic light to be 1500, which is 3 times more than the usual, and we're lowering the other traffic lights to 250, which is half of the original value. However, once we receive the reset signal, which is 0, it's going to reset them all back to 500. Next, we have the actual modification of the traffic light. Simply setting them to green while setting the others to be red. Basically, we're sending 1, 2, 4, 6. 1, as stated here, is for green, upper green. So, sending high to the pin 1 is going to result in the upper uh, upper traffic light to be green, and sending high to 2, 4, and 6 to the other uh, LEDs so that they are becoming red. Then we have the delay D1, which is if we need the north and traffic light to operate longer, it's gonna be here. It's gonna be 1500 because the data is 1. And we have a similar case for uh, when we want the other traffic lights, for example, the left traffic light to operate longer. This delay here is gonna make sure of that. Basically, Uh, when we have the traffic light, the northern traffic light as our priority traffic light, the delay here is going to be 1500, while for the others it's going to be 250. So it's operating on a much lower rate. And that concludes our demo for our project. I hope you liked it and have a good day.